Hey, good morning, afternoon, and evening, everyone. Welcome to the second session of the Hackfest Office Hour hosted by OpenShift Coffee Break. My name is Andrea Battaglia, and I'm going to be your host for this monthly session. And today with me, I have Tanya Ripo, who's the producer for the event, and he's one of the esteemed members of the Hackfest community. We are really looking forward to hear from our guests today. We have very special guests that will be able to give us several overviews on the business and the technical side of the Red Hat Hackfest. So get your espresso ready and enjoy the show. The agenda for today, we will have Michael telling us what's next with the Hackfest in APAC. And then we will have two Red Hat champions with us, Andreas and Frank, giving us an overview of Microshift. Feel free to put your questions in the chat anytime. We would like this to be a kind of a live show where people interact with the presenters. We are more than happy to reply your questions live. And for the people watching the episode offline, feel free to reach out to us anytime, and we will be happy to start conversation on the topic. So let's start with Michael. Michael and his team have worked hard to help the Hackfest team scaling the Red Hat Hackfest program in the Asia and Pacific region. So today it's my privilege to introduce him, Michael Geisler, Head of Partner Ecosystem Development in Asia and Pacific. And Michael, feel free to say a few words about yourself and tell us what the Hackfest means for the APAC region.
Yeah, thanks, Andrea. I've been at Red Hat for 6 years and well over 2 decades, probably closer to 3 decades in the industry, which is starting to feel my age, but across a range of roles. I started in pre-sales and technical roles, and I've been in sales and partner ecosystem roles probably for most of the last 15 years. So as Andrea said, I lead the APAC Red Hat ecosystem development team, and our team's really focused on working with partners, particularly around enablement and development, and also recruitment. So as Andrea said, we're kicking off the first Red Hat APAC Hackfest at the end of July, with the great support of Andrea and Tanya and team in EMEA. We're taking all of the best practices and experience that they've learned over running Hackfests over several times in EMEA, and trying to replicate that success in APAC. The great news is we've also got some fantastic sponsors in Intel and AWS. So we're looking forward to working with them and pulling together solutions with those key partners. In APAC, we've sort of significantly increased our investment in our partner ecosystem this year. So we've actually built out a brand new team to focus on partner enablement and drive more of these sort of proactive activities like Hackfest. Historically, we've really been a programmatic approach to enablement. I'm sure many of you are familiar with our partner training portal. And largely just most of our enablement activities have been focused on that. So now we want to sort of take the best practices that we've seen in EMEA around things like Hackfest, and we now have the team to support these sorts of activities. So we're going to be much more proactive around that. We've really, again, increased our focus on working with partners to develop and deliver solutions that solve problems for our customers, rather than just focusing on our Red Hat products and product training. We really want to get solutions that solve problems for our customers, that really deliver those tangible business outcomes. And the other area of focus for us is we've doubled down on our recruitment of new ISV partners in the region. And I think we've got about 150 new edge and hybrid ISV workloads on OpenShift now. And we're hoping that with Hackfest and the partners in Hackfest, that we'll find innovative ways to incorporate one or more of those ISVs into their solutions, as Hackfest is something that really supports one of our goals and ambitions to build more collaboration across our ecosystem. as you know, Red Hat has great products and technologies, but a container platform like OpenShift doesn't really deliver value to customers by itself. We all know customers have problems to solve, efficiencies to gain, and our partners understand these issues better than we do. So I really see Hackfest as this catalyst to foster the collaboration, to build the solutions that deliver these outcomes for customers and drive our respective business. And given that the APAC region has sort of become the factory of the world, and in APAC, Red Hat is increasing our investment quite significantly into the manufacturing sector. We've decided to use the same manufacturing use case that you've been using in EMEA. So I guess in summary, what are our expectations from Hackfest in APAC? And to us, it's a really key enablement activity for our partners. And bringing in partners like Intel and AWS and some of our ISV partners and driving enablement around those products and technologies. Collaboration across our ecosystem is a fundamental goal within the wider ecosystem team in APAC. And then we really want to deliver the basis of solutions that are going to solve those real customer problems, not only in manufacturing, but a solution that can be applied into other verticals like retail, oil and gas, and mining, and so forth. So Andrea, I'll hand back to you.
Yeah, thanks, Michael. That's an interesting perspective. So Asian Pacific, as you taught me, is a big and diverse market, and I have memory of the time we kicked off this collaboration between EMEA and APAC to roll out the Hackfest also in your region, and I was impressed from the diversity in terms also of language barriers or marketing needs. So considering this diversity, I would like to hear from you. What do you think we can do together for partners in terms of enablement? So what are your plans or your expectation? And also what's your vision from the customer standpoint? So what's in the Hackfest in APAC for the Red Hat customers?
So for the customers, we're really seeing the opportunity to, like I said earlier, to really find problems that we can solve for them using our ecosystem, bringing together our partners together to deliver that outcome or solve that problem for a customer. As individual partners, as I said, OpenShift doesn't solve a problem for a customer. It forms the platform and the basis to build a solution for a customer. An SI doesn't deliver a solution unless they're pulling together a number of different products and services and so forth. Intel doesn't solve a problem. AWS doesn't solve a problem. It's bringing all of these partners together and delivering an outcome for a customer, and that's what we really want to focus on. We want to move away from, what historically been a very product-centric approach to selling to our customers, and build these solutions that can deliver real tangible business outcomes for the customers.
Thanks, Michael. That's super interesting, and I believe in this methodology. So having a less product-centric and more customer challenge focused activity, proactiveness is crucial in this. And let me also say hi to Maverick, who's joining from Bangalore. So we have a broad audience today. Thanks also, Michael, for sharing and advertising on our social media. I heard you mentioning AWS, and I know also another co-sponsor is Intel. This synergy is fantastic, right? So as I had already the chance to share during previous OpenShift Coffee Break sessions hosted by Andrea, Natale, and the team, our vision from the Hackfest standpoint of a complex solution is always the synergy and collaboration and commitment of several entities. Could be hyperscaler, in your case, AWS, could be hardware vendors, more in general, like Intel, and other counterparts. And the crucial point, of course, the central pillar is the partner ecosystem. So how do you see the synergy and collaboration between several technology sponsors. And again, in your case, Red Hat, Intel, and AWS, proactively supporting the ecosystem. And also, what's your view of the roadmap of this implementation?
Yeah, so let's start with Intel, and I actually forgot to mention Intel actually awarded us the Global ISV Partner of the Year today, as Red Hat and APAC. So we've been working particularly closely with them for many years, but certainly over the last 12 months, we've spent a lot more time on proactively working with them. So Intel and Red Hat collaborate on customer POCs today. Intel co-funds a number of different POCs in the telco and FSI space in particular. And that's been a very successful partnership in that space. This year, we've really put a lot more focus on working with Intel to tap into their ecosystem. So let's go and find partners that Intel have that want to partner with Red Hat as well, or may not be aware of what Red Hat has to offer them. So at the moment, we have a pipeline of about 90 partners of Intel's in APAC that we're bringing on board. And Intel's obviously, I think in the case of Hackfest, has a long-term interest in this. They want to see this grow and grow and grow and continue over the coming years, because they want to bring their partners into this environment as well. And yeah, we've probably picked up about 10 new partners of Intel's, where Intel has actually proactively worked with us to bring them into the Red Hat ecosystem. So that's Intel. AWS, we've had a long-standing relationship with. We have Rosa as our sort of AWS native version of OpenShift, for those who aren't familiar with that. We've been working very closely with them recently, where we've been, actually many of the new ISVs that we're recruiting are subscribing to Rosa to deliver their solutions through AWS but on OpenShift. So that's been a really strong collaboration as well. So we find multiple angles with each of these partners, Intel and AWS, to work together and collaborate. So Hackfest is sort of a natural, I guess, progression of bringing those partners together with us and bringing in those wider partners of the ecosystem to work together.
That's great to hear. Thank you, Michael. And one last question for you, which jumped into my mind while you were talking. How do you see the collaboration? We have several partners, right? We want to identify. We have big system integrators, local system integrators, also ISVs, which are completely different because they create their own product starting from our, or from a certain technology stack, and they resell their product, right? Mm-hmm. How do you see different type of partners collaborating in such an initiative? So, and also, what's your view in terms of a framework after the Hackfest that puts together different partners to build and solve customer challenges?
Yeah, absolutely. So for this first Hackfest, we are keeping it to a smaller subset of our partners primarily. So in APAC, we have a partner program called OpenShift Practice Builder, where we've brought in particularly local systems integrators, but not so much the GSIs in this case, but the local systems integrators or regional systems integrators, and provided them incentives and other program benefits and so forth to encourage them to build practices around OpenShift, hence the name. So that's been a very successful program that we've run for many years. And we see Hackfest as a means to bring another level of engagement with those partners. And we'll focus on those partners for this version of Hackfest. But where the ISVs come into play is that we've started seeing and brokering relationships between those ISVs and our strongest OpenShift partners, because those ISVs who are building their solutions on OpenShift don't necessarily have the reach or capability to go and deliver a OpenShift-based solution in another country or another region. So those ISV partners, which might be based in Australia, for example, are looking for our strongest OpenShift partners in other countries, and EMEA eventually as well. So The partners are on this call. As I say, we have many ISVs who are looking for all sorts of channels to market, and particularly looking for strong partners in OpenShift and Rosa and Arrow and those sorts of technologies. So that's where we see the really strong link going forward as well.
Oh, well, fantastic, Michael. Thanks a lot. Thanks a lot, really. And let me also remind and stress this topic with our audience. The goal of our program initiative and now supported by Michael and supported by EMEA, and hopefully to be rolled out also in the other Red Hat region as soon as possible, is to put partners together. So we don't really want to keep boundaries there. Okay, technology is not really a boundary. There are tools and methodologies to enable and strengthen skills of our partner ecosystem. But the boundary could be geographical or could be language barrier that we want to address to make sure that we create a strong, diverse, and global partner ecosystem that can support technology vendors and customers all together. Now, the main goal here for Michael, myself, and the rest of the Hackfest contributors and sponsors is really to have a strong support to the partner ecosystem for our end customers. Always focusing on technology and technology stack, and specifically emerging technologies. And by emerging technologies, I mean Microshift. So thanks a lot, Michael. Microshift is the main topic of this second part of the Hackfest office hour. I can see here two gentlemen, Frank and Andreas. So just to quickly introduce the topic, guys, probably most of our live and offline attendees here have heard or tested Microshift. And I can see already Andreas smiling here. So Microshift is a project sponsored by the Red Hat Office of CTO. Today, Frank, who's the Microshift engineering team lead, will give us an overview of Microshift. And now it's the time for technical people to start asking questions, because Frank is even though he's not paid, he's here to answer all your questions. And also we have Andreas. Andreas is one of the most esteemed member of the Hackfest technical team. And he's also a champion when it's about infra, RHEL, and container technology. So he's our specialist. So guys, I hand over to you. Please say a few words about yourself. And then I guess Frank will introduce Microshift, and then Andreas will give us some presentation. Again, to the audience, and thanks everyone for joining. Feel free to ask questions. The guys are here to share as much as possible. So guys, stage is yours.
So hey everyone, first of all, thanks a lot for having me on this stream. Really glad to be here and talk about Microshift. My name is Frank Starsky. I'm a senior principal software engineer in Red Hat's office of the CTO. And I've joined Red Hat in 2014 at a time when the telco industry was embarking on this journey to move away from bespoke hardware, software into cloud and put all the infrastructure and operations and processes onto the cloud. And my first task was actually to evangelize, if you want, open source or upstream first open source in those communities. And eventually I built a team that would extend first OpenStack and OpenShift, then OpenShift with all the features that they would need to run telco 5G workloads. We were working closely with our partners, our ecosystem, because there's like just a ton of experience we can gain from doing Hackfest, from working with partners, etc. And also our product engineering. And the thing we did is we always worked on a horizontal platform, because it turns out a lot of the features that you need in telco, you also need in other industries. And then in 2018, I was asked to do exactly the same thing for edge computing, right? Because we had many different pockets or industry-specific pockets in Red Hat, and we needed to have a cross-portfolio, cross-vertical view. And so now I'm leading this, the area of edge computing in the office of the CTO. My team is working on several projects to enhance the Red Hat portfolio for the edge. One One of the projects, for example, is infrastructure and edge application blueprints that you can use in a GitOps context and use as a template to stamp out edge deployments, something we now call Red Hat validated patterns. And Microshift is actually the most recent project that came out of my team, and I think we're going to talk a little bit more about it in a minute after maybe Andreas introduces himself.
Well, thanks, Frank. So my name is Andreas Stolzenberger. I've been with Red Hat for almost 10 years now. I'm a principal solution architect, and I started with working with large-scale customers in Germany and moved over to partners and partner enablement. And I joined the Hackfest team because I'm the only guy that doesn't code. I'm the one who's responsible for the infrastructure so that the guys that do code have something to execute on. And we came up with the, Andrea came up with the idea of the Hackfest architecture with a data center with an edge. And we needed to find something where we can actually execute on the edge outside. And when we started that, we built something with, installing an edge device like an Intel Fitlet with RHEL, and then taking the containerized applications that we have and use them with Podman until we stumbled across Frank's Microshift project that we've embraced ever since, because for us, that's the logic extension from a large infrastructure where the customers have the data center running OpenShift clusters to an edge with a maybe single node OpenShift, and then going directly on the device, on the IoT device, and they want to have their applications go all the way with the same container image, with the same settings around it. So Microshift as the miniature version of OpenShift to extend to the edge device is the absolute logic decision to go, and that's why we embrace that in our architecture, and we're going to use it from now on forwards to actually run the code there, and that's my part in the team to get that up and running, and that's why I'm talking with you here. So and yeah, so back to Frank to show us how it actually works.
Excellent. Thank you, Andreas. Let me share slides, and I promise you I will keep it short. Just use them as a background, just to give you a little bit of context on where we want to go with Microshift. And the reason is because its reason for existence really because there is a world of use cases that's very different from the cloud and data center use cases that OpenShift has been built for. So of course, I'm not paid at all to say that OpenShift is awesome. If you're running on the cloud and data centers and then ever smaller and smaller server infrastructures, running them in pretty controlled environments. But then there is a whole different set of edge computing use cases which involve what I call field deployed edge devices. And in this world of field deployed edge devices, devices are, if you want, single board computers, systems on chip, system on modules that, unlike servers, have extremely limited resources and are not typically not extensible. So if you look at the left, I'm just giving you some examples of these platforms. And what's interesting in that edge device space is that a family of platforms typically has a preferred use case, or the other way around, right? So if, for example, if you have AI/ML use cases, then the NVIDIA Jetson platform is super popular just because they give you a really, really good performance per dollar or performance per watt of energy that you invest. Likewise, the NXP IMX platform is super popular if you have like media kiosk-like applications. Xilinx UltraScale is a platform that people who are into signals processing, FPGAs, etc., prefer. And then, of course, all of us makers, they like to use the Raspberry Pi 4. And apart from resource limitations, a lot of things change when you deploy or use these devices. For example, the whole procurement provisioning process, right? So it's typical to have those devices imaged at the factory, shipped directly on site, where a non-technical person just mounts them to a headrail or to the wall or wherever, plugs in the power over Ethernet cable and walks away, right? So that's kind of the kind of provisioning you have. There's no ISO-based installation, a PXE boot, or none of that. And one of the reasons is also that these devices do not have any out-of-band management, right? So there is no IPMI, no BMC. And the consequence of that is that these devices are not remotely recoverable over the network in case you push a bad software or configuration update. Right? The other part is that these devices are field deployed. So the deployment and maintenance of these devices is super expensive. You need to do truck rolls, or in case of some of our customers, helicopter runs. There's low physical access control. There's severe networking constraints. So think about devices that are only connected maybe once a week, connected over a network that's like on the order of megabits per second, or super expensive because you pay by the megabyte. So there are a lot of challenges related to this network environment. And when you look at what Red Hat then did, is to say, hey, we need an operating system that is tuned especially for this set of use cases. Of course, it's not going to be a new operating system. It's basically a deployment configuration of our Red Hat Enterprise Linux, right? And so Red Hat has been working over the last year plus to add features to Red Hat Enterprise Linux exactly for that use case. And what those features are is basically the ability to create RPM OS tree-based system images. Why do you do system images? Because like on your cell phone, right, you want to have the whole operating system, its configuration, and the default set of applications maybe into a single image that you can develop as a system image, you test it, or you create it as an image, and you deploy it as an image out to the devices in the field, and thereby you ensure that all devices look almost exactly the same, and that helps you really with on the operations side, because the less variation you have between devices, the easier to troubleshoot in case there are problems. And then there's a tool called Image Builder that takes a blueprint, so a text description of what is the operating system, what do you want to embed into that system image, builds it, and allows you to publish this OS tree repo. OS tree repos OS trees are interesting because you update and roll back transactionally the operating system, right? That means there's no more, DNF update on each individual device. You're basically updating the golden file system if you want, and then there are very efficient mechanisms to delta download from whatever version the devices are on to the target version in this RPM OS tree repo. And because these file systems are actually A/B installations, so they're both present on the system at the same time, the currently running one and the one for the update, there's the possibility to basically install or stage the new file system. And only when it's complete, you can completely lose network connectivity if you want, right? The update is actually no longer requiring the network. So you basically just reboot, and 10 seconds later, and it's really going quickly like that, you're in the new file system. And then you have the ability to add health checks and say, is the file system coming up correctly? And if not, automatically the system rolls back to its previously known good state. And the reason I'm giving you this context is because when we talk about Microshift, it is actually an OpenShift exactly for this device edge. And so we are leveraging all those features that RHEL for Edge gives customers, and then build on top of it. So what Microshift is basically an essential subset of OpenShift Kubernetes in a small form factor and optimized for these field deployed edge devices. A lot of our customers actually want to embed Microshift as a kind of tiny Kubernetes runtime into their products. So we also, of course, want to make it easy to embed Microshift itself as well as Kubernetes workloads. And as I said, because we are inheriting RHEL for Edge features, the whole installation process of Microshift will eventually just be, procure a device or FIDO device on board, plug it into the network, and the FIDO device on board in RHEL will ensure that these devices automatically discover their owner and their owner's management system and onboard into that management system. And they will then already have, if a customer chooses to embed Microshift, this Microshift runtime embedded into the system image, right? And then you can deploy Kubernetes applications in one of two ways. You can use this combination of RHEL, FireEdge, and Microshift as a classical, say, in a hosted model. So you can just install, let's say, a management agent on that device that automatically pulls from Git or via ACM and the advanced cluster management the target workloads that you want to run dynamically, right? Add and remove. But we also have customers that are super interested in actually embedding Kubernetes applications into the system image. So if you think about, I don't know, and your phone again, there are some applications that come pre-installed with the operating system, right? There are some that you download at runtime through the App Store, and we want to support both of these models actually. And the nice thing about doing that with RPM OS trees is that you actually have the possibility to download updates of the RPM tree over the network, or you can do a sneaker network, right? You can basically take a USB stick with the new RPM OS tree version, plug it into the device. The USB stick, the device is protected using USB guards. So you're basically validating that this USB stick is in fact signed by the device owner, and the content is signed. And only then you basically copy the new version onto the device and then automatically update into the new version. And so we like to keep this just as two different ways of doing transport. Maybe just lastly, the goal is workload portability with OpenShift. And I need to caveat this because what we want is that these Microshift deployments are runtime environments, right? They're not meant as build clusters like on OpenShift. So there's a lot of stuff we cut out that's mainly using supporting the the build host or build cluster use case that we don't need at the edge. And the other thing we're changing is that with OpenShift, OpenShift takes care of the operating system, the infrastructure, and all of those things for you, right? It abstracts from it. It controls it like top down, if you want. And because of the use case of Microshift being embedded into somebody else's system, we actually do the opposite. So Microshift is just there for running workloads. It is not meant to control the operating system, its configuration, etc. It's the job of the user, to tune RHEL for their specific use case, and then Microshift is just there to, if you want, expose those resources from the operating system into the cluster. But once the cluster is up, the Microshift cluster is up, the way you can manage workloads should look the same from our perspective, no matter whether it's OpenShift or Microshift. Sorry, that was already taking a little bit longer than I expected, but I hope that context was useful.
Sure, and I could illustrate what he was just presenting on slides and show you how simply it really is to build the image and get it running.
And that's fantastic. Thanks, Andreas and Frank. That your presentation was interesting and quite insightful, to be honest. So that actually made a question jump into my mind. As you are the team leader of the engineering team for Microshift, I would like to hear from you. What's the plan from the Red Hat standpoint, and what's your idea of the Microshift development as a project and potentially as a product in the short or mid term?
Yes, absolutely. So so far or to date, Microshift is a community project. is a project, not a product, right, out of my team. And it was basically used to test the waters, if you want, with customers and see where do we hit the nail on some of their use cases, what do customers actually want. And we have had collected this feedback to now better understand what the priorities of our customers are. Recently, there's been this decision, we are going to productize Microshift. So by the end of this year, there is going to be first tech preview, if you want, of Microshift, basically released at or around the OpenShift 4.12 release, and still, if you want, limited availability in the sense that we need to basically want to limit the production grade support to a smaller set of customers first, right? But always Microshift will be available and downloadable for everyone, of course. And then hopefully with 4.13, we will be able to move to general availability. What we're doing right now is, again, focusing on integrating Microshift into our production chain. So as you can imagine, the integration into CI, producing all of our artifacts as part of the Red Hat production chain, signing the content, having the documentation in place, having the QA in place. That's a lot of work that's needed to actually productize something. And so we're going through that mainly. And the other part is that we basically want to get Microshift into its kind of final shape for the first product release. So we're basically looking into, can we provide like a different or better networking or storage provider? We've, as I said before, we are pruning the APIs to really laser focus on those production deployments as runtime. And unfortunately, with the side effects that a lot of our community stuff currently is a bit, I say, understaffed, right? But we'd be super thrilled to have, contribution on the community side, because our focus is on Microshift RPM. The reason is, as I said, we want to be able to embed those instances into RPM OS trees, and less the containerized version as a consequence. So after the first release is out the door, then we can basically breathe hard again and catch breath and then focus on where we're going to go from there. And there's like a ton of stuff around, integration with RHEL for Edge, so ensuring that you have like full disk encryption and with keys stored in the TPM, that you have this update process that I mentioned in place. So a lot of that stuff already exists in RHEL. It's just a matter of formalizing and QAing it. Multi-node is not our initial priority, to be honest, just because customers' feedback was, hey, we want to start with single node first, probably need to go HA and multi-node in the future, but right now, all we want is, one way of developing software, one way of operating software, no matter whether it's cloud or near edge or on this device edge. So that's going to be the focus for us.
Thank you, Frank. That's an awesome perspective, and I believe that's definitely the way to go. Mr. Stolzenberger, are we ready? Because actually, Frank gave you also an interesting point to discuss Microshift usability today. So, stage is yours.
So, Frank was showcasing the Edge installer and how you would create an Edge image, and that's what we were using for the hackathon or for the Hackfest. And if you bring up my screen, I can show you what we were using in the past and what we're going to do in the future. This is just the cockpit session of a RHEL image. And that RHEL virtual machine has the image builder installed. And that's the one that Frank was referring to, because what you can simply do here is you create an image, you give it a name, and then you add packages, and it's merely drag and drop. So this was the image that we actually built for the first run of the hackathon. So we put the cockpit and pod and stuff in it. And from there, you literally go and say create image, and then you say RHEL for Edge commit. And what you get off that is a simple structure with packets that you just put on a web server, and then you can install it from there. So the next step in our progress, and as Frank already mentioned, will be to rip out the Podman and the Podman Docker packets, and instead come in with Microshift. So I already built that, but sadly enough, I built it on a Fedora system that I deleted. So the image builder with actually Microshift in it was on a virtual machine. But anyway, if you are interested in actually using and trying Microshift, the documentation is right here on microshift.io. It is pretty simple and straightforward, and actually for a test environment that I'm using, this is all you need to do. So I got a Fedora 35 system, and it is literally this 4 lines of infrastructure that you have to do. That's all there is. And then you will install Microshift on a Fedora virtual machine, physical machine. I'm using one of the old notebooks that I no longer use in production, and I run that as a Microshift server. So basically, from the technology perspective, we use Cryo, which is the engine behind Kubernetes, the container engine, so we don't need Podman or Docker, something as fat as that. And so that's what you install, the Cryo tools. And then Frank's team created an RPM where you can install the Microshift off in a Copper environment, in a Copper repository, and that's all there is. So there is a description saying that you can run Microshift as a containerized version, but as Frank mentioned, they're focusing on the RPM build, because if you run it as containerized itself, you would have a Podman container running Microshift that then controls Cryo, which doesn't make a lot of sense. So you just install it as pure Microshift. So that's basically it, and this is how you can install it. And just as a practical thing, it's not only for Edge things. That's the wrong window. That's the right window. What I have here, for example, is a Microshift environment that I use for testing, for development, and these things. So in this case, as you can see, I've been playing around with a couple of databases, running them containerized, built the stateful sets, built the YAML codes to create these applications. And here's even a Microsoft SQL server running on top of Fedora inside Microshift, which is a pretty simple setup, and a Cassandra cluster. And as you can see from my t-shirt, if you mentioned EA, so I'm doing a lot with Ansible. And for my tests with Ansible, that's basically what I do. And this is what also is working brilliantly on Microshift is I have the AWX operator. So all the Kubernetes operators, or most of them, work on top of Microshift the same way as they would on OpenShift. So in this case, I rolled out the AWX operator, which is the operator behind the upstream Ansible controller, and then that one rolled out a Postgres database and the AWX setup. And then you can use it for test and development purposes. Likewise here, so you have your AWX setup, and as you can see, you can also use concepts like roots. So you see the C name for the system that points out. So the X230 F Fedora 31, that's the name of the server, and then the C name on top of it points to that application which was built as a root. So if you take a look at the routes here. So you see that one as forwarding to the service that I created for AWX, and then you have the service here, which is that one. And this is where you can also use the Microshift for is the development and the testing, and then whatever you do here, take it forward to your OpenShift deployments. That's just as a small glimpse. And again, if you're not too happy with the command line only, there's an open source project called K9S, which gives you this wonderful text UI in front of Kubernetes. And that just for a simple and small demo of how things work and how you can roll out the stuff easily. So with that, do we have questions on the matter and options?
Thanks, Andreas. That's fantastic, and that also helps with understanding what we can do and what our audience can do to support Frank and his team in testing and contributing to the Microshift development. I can see no question in the chat from our audience, but I actually have a question for you, Andreas, if I may. So you are in the partner development for the EMEA ecosystem for a long time, right? So you have a quite extended and large experience. So what are your thoughts and or plans for the adoption of Microshift by our partners?
So I include that really in partner enablement, especially when it comes to Ansible. I see that not only as running on the edge, but I also see that as development platform. And the example that I just shared with you, the AWX here, it's just a very simple click or just one command to get an AWX, upstream Ansible controller, up and running. So in the Ansible community, what we also are doing is go to everything as code. So even the configuration of the Ansible controller itself comes as code. So, you know, if you have played with Ansible, if you have used Tower, if you have used controller, you see all the configurations and templates and workflow and all that kind of stuff that you have defined in your automation tool. That is actually YAML code. You put that in a GitHub, and then you have an Ansible playbook to actually deploy the Ansible controller configuration. And the way you test that is set up a Microshift environment. So you set up a Microshift environment, you get the AWX operator on it, you just fire up an AWX instance, which takes literally seconds to get up and running. Then you take your prepared automation to create your configured Ansible controller out of an empty AWX setup. You run the playbook, you test it, and if everything's not the way you expected it, you just delete the instance and bring up a new one, correct your code, do the same. So this is a great platform for testing and developing, and then whatever you create here, you put it on OpenShift. So as an example, I just did some educational stuff on how to run a database inside an OpenShift or Kubernetes environment. And actually the code, how to create the stateful sets, I created on Microshift because it's easy, it's simple, it's small, it runs inside a virtual machine. And once you got all your code ready, you can take it then and go to the OpenShift environment and run it there. And for many customers, probably that will also be the case because their developers have to work with something which is as close to the real thing as possible. But on the other hand, be simpler and cheaper. So because, you know, you can have your OpenShift on AWS, on Azure, or wherever. But, you know, developers, they don't want to be online all the time. They want to sit on the beach with their notebook underneath the umbrella, be offline, and still do work. That's what they can do with that. So you can sit on a plane, fire up your Microshift inside the virtual machine on your notebook, and then continue to work being offline. And that's one of the major aspects from my perspective. and make it easy for especially people that come from monolithic applications and need to learn the Kubernetes, learn the scale out way, and start playing with applications, ripping them into pieces in containers and these things. And Microshift will give them a very easy entry level to get that without the need of starting with a multi-node OpenShift cluster first. And then, of course, what Frank is doing with industry customers, especially. Now, think about the future of that. You might have a car, and inside the car, the only thing you have is an ARM device with Microshift on it. And that's actually controlling your stuff, and that's interfacing with your front end, and you can do a simple over-the-air update of a container with your navigational system without, you know how it is. You have to go to the garage, and then they have to plug in your 25 control systems to 25 special systems. I had my car at BMW for 2 days because it took them all night to update my software, and that's a thing of the past. Simple thing, a simple system, Microshift on it, drop a new container in it, go.
Thanks, Andreas. That's definitely awesome. Yeah, it is definitely awesome. So we have a few minutes left. I would like to ask a couple of quick questions if we can use the last few minutes we have. So first of all, Frank, let me ask you, as Andrea mentioned an automotive use case, is there any use case you would like to mention here? Because Microshift is already adopted by some partners and customers. So is there anything interesting you would like to share with us?
Yeah. So, automotive is, of course, a challenging space because of all the safety criticality, right? So as long as it's safety critical workload, you want to keep the complexity of the code as small as possible, which is why we are at Red Hat actually looking into smaller form factors than RHEL, is this RHEL in-vehicle operating system, right? But as Andreas said, there are maybe some other workloads that are not safety critical where maybe you might see Microshift at one day, right? The other part is we have a customer from the industrial space looking into embedding Microshift into their portfolio of industrial IoT gateways. So that's a pretty good use case. Or we have customers wanting to use it on autonomous vehicles, right? On robots, on drones, everywhere where network connectivity is probably scarce, and they want to run Microshift, for example, on RHEL on the NVIDIA Jetson family of boards that I mentioned at the very beginning. And maybe from my perspective, the most fun use case is that Microshift is actually currently running in space. So just end of May, there was a Falcon 9 Block 5 rocket that launched a CubeSat satellite, like a micro satellite, if you want, of IBM Space Tech into orbit. And IBM Space Tech's use case is they want to, as they say, democratize space, right? So they want to give school-age children the possibility to basically develop their own little application locally, uplink it into the satellite, and then access the satellite's cameras and sensor feeds to do some processing and send the results down. So that's really fun. And IBM Space Tech approached my team because they said, well, we actually plan to launch on a Raspberry Pi on the satellite. So this satellite is actually running a Raspberry Pi. I don't know why, but so obviously they are extremely not only space constrained, but also energy constrained because those boards create heat, and heat is always a problem in space, as you can imagine. And so they actually asked us whether they could use Microshift on that satellite to run those students' workloads and have consistency with, their kind of the development environment they make available on OpenShift in the cloud, right? And they're actually running Microshift in a very special mode, which we call like the all-in-one container image. And the reason is because they want the ability to quickly suspend and so freeze and also thaw the Microshift instance, including the respective workloads to conserve energy, or basically, just kill the container, start a new one, and very rapidly have a fresh instance running. So that's kind of their use case. And together with their team, we watched the launch and the deployment of that satellite, and it was super, super exciting.
Yeah, this is definitely impressive, Frank. So, wow. Thanks for this. Unfortunately, we are almost at the top of our time. So I would say to close here the session, and let me first of all thank our producer, Tanya Repo. Thanks a lot for the amazing job and putting together all of us. Thanks to our special guests today. So Michael, Frank, and Andreas, sorry. So I really enjoyed the session. For our audience, thanks a lot for joining. If you have any questions, please feel free to reach out to us anytime. Our also special guest from Natale's team, Andrea Biali, he supported us with the production and the show overall setup. Thanks a lot, Andrea. It's been a fantastic opportunity to stay here all together. A quick overview of what's going to happen in the next episode. So first of all, we will launch the third session of the Hackfest Office Hour on the last Wednesday of July. As usual, we go live every last Wednesday of every month, same time slot. We will have already some presenters. So we will have Gunther Herold, the head of EMEA Partner Development Team, and we will give you an overview of the next use case the Hackfest technical team is actually implementing. Last but not least, we are trying to collect some additional topics, and we would love also to, considering we spoke about Microshift today, our goal is to talk about some control and automation to be adopted by the Hackfest community team. It's also advanced cluster management, so aka ACM, and that's basically the rough agenda for the next meeting. With that, I want again to say thank you, everyone. Guys, any last comments from you? Also, Michael.
Just thanks for everyone for joining. It was a great session.
Same here. Thanks for having me, and let me talk about my favorite topic currently.
Yep. Thanks for having me and showcasing some things on Frank's wonderful product.
Thanks, everyone. See you soon.